Students, today we have a chapter Structure of Atom. That is a chapter 4 of class 9th Science. In this chapter we are going to study about different models of atoms like Thomson's atom model, Rutherford's atom model and Bohr atom model. Let us first look at the charged particles which are present in the matter, which have been the three subatomic particles which are present in an atom, that is electrons, protons and neutrons. Here electrons have got a negative charge, protons have got a positive charge and neutrons have no charge, that is 0. These are the three subatomic particles. Regarding their discovery, in 1900 the first particle has been discovered by J.J. Thomson, which was negative in charge. In 1886, Goldstein has discovered the particles which is protons which are positive in charge. He discovered them from a experiment discharge tube in the canal race. And in 1932, Chadwick has discovered neutrons which are having no charge. Now let us come to the first model of the atom, that is Thomson's model of atom. According to J.J. Thomson, the atom would look like a Christmas cake or a plum pudding model. That is the other name of this model, plum pudding model. You can also consider it as a watermelon, wherein the full positive charge is spread around the red area and there are electrons embedded into them, just like here it is shown. So what are the 2 points? He proposed that an atom consists of a positively charged sphere and the electrons are embedded in it. The second point is the negative and positive charges are equal in magnitude. So the atom is electrically neutral. So this is the first proposed model of an atom, J.J. Thomson's plum pudding model. Now let us go to the second model of atom. Before going to the second model is actually Rutherford's model of atom. And before going to Rutherford's model, we will see the alpha scattering experiment which was done by Rutherford. He allowed a beam of fast moving alpha particles having positive charge to a very thin gold foil. Now, what is the purpose of taking this gold foil? It is because gold is the most malleable metal, or most thinnest sheet can be obtained from gold. That is why he has selected gold metal to pass on the alpha particles, that is the positively charged radiations he passed to the thin gold foil. Now what you are seeing is the gold atoms, and when the alpha radiations, that is these arrows, are going through the gold atom, most of them are going straight. Most of the alpha particles are moving straight through the gold foil. Some of them are deflected by slight angles, whereas some are deflected exactly 180 degree. That means just opposite they are deflected. Now you can see why they are deflecting, because they are hitting the center region. So based on this experiment, Rutherford proposed a model. And what was that model? That atom is something which has got a very small center region, and that center region he named as nucleus. And all the other electrons, if they are present, they are having very less mass and they are rotating around the nucleus. And this model is somewhat considered as our solar system, where the center of the solar system is sun. So here nucleus is the center and the electrons are revolving around, just like planets are revolving around the sun. So that was the model proposed by Rutherford. What are the conclusions which he derived, which made him to make this model, that is Rutherford's model of atom? This is also called as nuclear model of atom. Most of the space inside the atom is empty. The atom has a small nucleus which is a positive charge. Some of the alpha particles were deflected by small angles. and the size of the nucleus is very small. Based on that, this is the atom model which is proposed by Rutherford. An atom has a positively charged nucleus at its center. The mass of the atom is in the nucleus, that is in the smallest region, that is the center of the atom. All the masses are enclosed. The electrons are revolving around the nucleus in different orbits. The size is very, very small as compared to the size of the atom. You can compare it to a football placed in a football ground. That much small is the center of the atom, that is the nucleus. Here you can see the model, but there is a defect for this model. Let us see what is the defect or limitation of this model. In Rutherford's atom model, it is supposed that the electrons are revolving around the nucleus, but it is not told exactly where it is revolving. Just some paths were told. Now, electron is a charged particle. A charged particle, when it undergoes acceleration, that is, when it is rotating in a circular motion, it would lose energy, according to the Maxwell's theory, and which was actually proposed very late after the Rutherford's atom model was proposed. Now, due to which the revolving electrons will always lose their energy and they will be falling into the nucleus. So, as such, the atom is unstable, and that is why the Rutherford's atom model was discarded, and later the Bohr atomic model came into existence. In Bohr atomic model, some points are the same. An atom has a positively charged nucleus at its center, and most of the mass of the atom is in the nucleus. The electrons revolve around the nucleus in special orbits called as discrete orbits. They are also sometimes called as shells. These orbits are shells or energy levels. This is very important term, that energy levels are there. There is a fixed energy for the orbits. And when an electron is present in one particular shell or energy level, its energy will not change. So these energy levels are represented as K, L, M, N. They are the designations used, or they can be numbered like 1, 2, 3, 4 from the distance from the nucleus. While revolving in the discrete orbits, electrons do not radiate energy. These are the points made by Bohr's model of atom. Now next we will look at what are the different atom models for electron elements based on Bohr. In order to that, we should know the atomic number and mass number of elements and the distribution of electrons in different shells. So here we will straight go to the 2n square formula. According to the 2n square formula, how many electrons you can have in one shell? So if you are taking the first shell K, that is n is equal to 1, so you will have 2 electrons. The second shell is L, where n is equal to 2, you have 2 into 2 square, that's equal to 8 electrons. The M shell, n is equal to 3, so 18 electrons. And fourth shell, N shell, n is equal to 4, that is 32 electrons. So 2, 8, 18, 32. The maximum number of electrons that can be filled in the outermost shell is 8. Electrons cannot be filled in a shell unless the inner shells are filled. That means you have to start filling from K, then L, then M, then N. That is the way. Now just look at this table. In this table, we are given the elements from hydrogen to argon, their symbols, the atomic numbers starting from 1 to 18, the number of protons, number of neutrons, and number of electrons. The distributions are mentioned here and their valencies. We'll talk about this term at the end. Now let us start drawing the elements. We will take some elements from here like hydrogen, carbon, sodium, and sulfur. Let us take hydrogen first. The symbol of hydrogen is H, atomic number is 1, and mass number is 1. The center part of the atom is the nucleus. It has got 1 proton and 1 electron. 1 proton and 1 electron, and 1 minus 1, it has got 0 neutron. Since it has only 1 electron, we'll draw only the first shell and we'll draw an electron there. This is the structure for hydrogen. Next one, which one we have taken? Carbon. Let us draw carbon. Carbon C612. So 6 protons and 6 electrons. 12 minus 6 neutrons. Here is the nucleus. You have got 6 protons, so you'll put 6, and 12 minus 6, 6 neutrons. Now, the 6 electrons, how you can represent it? 2, 4. So in the first shell you have got 2 electrons. In the second shell you have got 1, 2, 3, 4. 4 electrons. Next one, we can draw sodium. Na1123. Center part is the nucleus. You have got 11 protons and 23 minus 11, that is 12 neutrons. Now let us draw the shells. How many shells do you require? 2, 8. 8 plus 2, 10 plus 1, 11. So you require 3 shells. The first shell, 2 electrons. Second shell, 8 electrons. And third shell, 1 electron. Last element is sulfur. 16s32. The center of the nucleus is having 16 protons. If you subtract, you will get 16 only, 16 neutrons. If you write the electronic configuration, you will get 2, 8, 6. So 2 electrons in the first shell. Eight electrons in the second shell. 1, 2, 3, 4, 5, 6. 6 electrons in the last shell. So in this way you can draw the Bohr atomic models of elements. Here you can see all the first 18 elements. So try to draw it in your notebook.